Hey everyone, I hope you're doing well today. In this video, we have 10 more practice problems dealing with one-step equations. While I've already made 3 separate videos on just addition, just subtraction, and just multiplication one-step equations, this video is going to be focused on one-step equations that only have division as their operation. To solve each of these equations that have division as their operation, there are really 2 properties that we need to use. The inverse operation of division is multiplication, so for each of these equations, we're going to use the multiplication property of equality. That just means we're going to multiply both sides of the equation by a given number. Once we use the multiplication property of equality, we should always get a coefficient of 1 in front of the variable, and then we can just use the identity property of multiplication and drop that 1. These will be the 2 properties we'll use to solve each of these one-step equations that have division as the operation. Throughout this video, we're going to cover 10 different examples that look like this, and these, and some like this, and we'll finish up with these 2. In all 10 of these examples, notice the fraction bars. You have to remember that fraction bars are just another way of showing division. Since each of these equations have division as their operation, we're going to use the multiplication property of equality, and then the identity property of multiplication to solve each of them. Let's get right into some practice problems now. I encourage you to grab some paper, something to write with, and let's do some math together. For example 1, we have x over 3 is equal to 12. So when we have this fraction, remember that this over 3 is really just meaning x divided by 3. The inverse operation of dividing by 3 is going to be multiplying by 3, so we're going to go ahead and multiply both sides by 3. By doing so, we're using the multiplication property of equality. On the left side, 3 is just 3 over 1 multiplied by this x over 3 that we have on the left side of the equation, and on the right side we have 12 multiplied by this 3. On the left side, we're just multiplying fractions so we can cross-cancel these 3's because they have a common factor of 3 each and they become 1's, and so we can simplify the left side to just saying we have 1 times x. On the right side, 12 times 3 is equal to 36, so we can go ahead and write that. The identity property of multiplication tells us we can drop the 1, so we can just write our solution is going to be x equals 36. And this should make sense to us because if we take this 36 and substitute it in right here for x, 36 divided by 3 is equal to 12. For example 2, we have the equation 7 is equal to y over 15, or y divided by 15. So if we want to get rid of that divided by 15, we're going to have to multiply by 15 on the right side and multiply by 15 on the left side. By doing so, we're using the multiplication property of equality. Rewriting this, we have 15 multiplied by 7 on the left side, and on the right side we have y over 15, but we're going to be multiplying this by 15 over 1. On the left, 15 times 7 is going to be 135, so go ahead and write that. And on the right side, these 15's are going to cross-cancel with each other and become 1's, so we can just write 1 times y on the right side of the equation. We can go ahead and drop that 1 and write 135 is equal to y, or turn that around and say that the value of y is equal to 135. There's our solution. You can check this, but 135 substituted in for y, 135 divided by 15 does equal 7. For example 3, we have z over 6 is equal to negative 9. So remember, this is z divided by 6, and to get rid of that divided by 6, we're going to multiply the left side by 6 and multiply the right side by 6. Rewriting the left side so we can multiply these fractions, 6 is just 6 over 1, and we're going to multiply that by z over 6, or z divided by 6, and on the right side we still have this negative 9 multiplied by 6. Just like we planned, these 6's are going to cross-cancel to become 1's, and we can write 1 times z, or 1z, on the left side of the equation. On the right side, 9 times 6 is equal to 54, so negative 9 times 6 is equal to negative 54. If we know that 1 times z is equal to negative 54, then z must equal negative 54. There's our solution. There's where we use the multiplication property of equality, and there's where we use the identity property of multiplication. Our solution makes sense here because negative 54 divided by 6 does equal negative 9. For example 4, we have negative 16 is equal to a over 4. This just means a divided by 4, so to get a alone, we're going to have to multiply the right side by 4 and multiply the left side by 4. Rewriting this, we're going to have 4 multiplied by the negative 16 on the left side of the equation, and on the right side, we're going to have this a over 4, which we originally had, and we're multiplying that by 4, which is 4 over 1. 4 times negative 16 is going to equal negative 64 on the left side. And on the right side, these 4's are going to cross-cancel with each other and become 1's, so we can write 1 times a. Dropping the 1, we can say that negative 64 is equal to a, and turning it around, we can say that a is equal to negative 64. There's our solution. Negative 64 divided by 4 does equal negative 16. For example 5, we have b over negative 2 is equal to negative 19. Since we're taking b and dividing it by negative 2, we're going to go ahead and undo that by multiplying both sides by negative 2. Rewriting this, we can write the negative 2 as negative 2 over 1 multiplied by the b over the negative 2 that we started with, and on the right side, let's just leave that alone for now and keep that as negative 19 multiplied by that negative 2. And just like we wanted them to, these negative 2's are going to cross cancel to make 1's, and we have 1 times b on the left side of the equation. On the right side, a negative times a negative is a positive, so we have positive 38. Let's go ahead and drop that 1 and say that our solution is b is equal to 38. This makes sense because 38 divided by that negative 2 is equal to negative 19. And here's where we used our two properties. For example 6, we have 4.7 is equal to c over 3. Since we're dividing by 3, let's go ahead and multiply both sides by 3 to get rid of the divided by 3. Rewriting this, on the left side this is 3 times the 4.7, just going to go ahead and write it just like that. And on the right side, let's write c over 3, which we originally had, and we're multiplying this by 3, which is 3 over 1 as a fraction. 3 times 4.7 is equal to 14.1, so we'll go ahead and write that on the left side of the equation. And on the right side, these 3's are going to cross cancel, and we're going to be left with 1 times c on the right side. We don't need to write the 1 as a coefficient, so we can say that 14.1 is equal to c, or turn it around and say that c is equal to 14.1. There's our solution. Checking this, 14.1 divided by 3 does equal 4.7. And as usual, these are the two properties we used. For example 7, we have d over 0.3 is equal to 0.8. So we know d is dividing by the 0.3, so to undo that, we're going to multiply both sides by 0.3 or 0.3, whichever one you want to write is fine. Rewriting 0.3 as a fraction, we can write 0.3 over 1 multiplied by that d over 0.3 that we started with, and on the right side of the equation, we still have the 0.8 or 0.8 being multiplied by this 0.3. These 0.3's are going to cross cancel and become a 1, so we can write 1 times d on the left side. And on the right side, 0.8 times 0.3, well, 3 times 8 is 24, so we need 2 decimal places, so this is going to be 0.24 or 0.24. Dropping the 1, we can say the value of d is equal to 0.24, or 24 hundredths. 24 hundredths divided by 0.3, or 3 tenths, is equal to 8 tenths. Even though we're using decimals, we still use the same properties. For example 8, we have e over 3 is equal to 2 1/3. So to balance out this divided by 3 on the left side, let's go ahead and multiply by 3, but we have to do it on the left, then we have to do that on the right. Rewriting 3 as a fraction, we can write 3 over 1, and we're going to multiply that by e over 3 that we started with, and this is going to be equal to the 2 1/3 on the right side, multiplied by the 3 that we put there ourselves. On the left side, these 3's will cross cancel to make 1's, and we can just write 1 times e. And on the right side, we have a little bit of work to do here. So 2 1/3 multiplied by 3, so we have to turn this into an improper fraction, so 2 times 3 is going to be 6, plus 1 is going to be 7. So this is really just going to be 7/3 multiplied by 3, which is 3 over 1. We can go ahead and cross cancel these 3's to make 1 and 1 since they have a common factor of 3. And when we multiply here, that's going to be equal to 7 over 1, or just simplified down, that is 7. 2 1/3 times 3 is equal to 7 wholes. Dropping that 1, we can say the value of e is equal to 7. There's our solution. This makes sense because if you take 7 and divide it into 3 equal parts, you'll have 2 1/3 in each of those parts. We used the multiplication property of equality when we multiplied both sides by 3, and we used the identity property of multiplication when we didn't write the 1 as a coefficient. For example 9, we have the equation 5 1/2 is equal to f divided by 8. So we know this is divided by 8, so to counteract that, we're going to multiply by 8 on the right side, but if we do it on the right, we have to absolutely do this on the left. Rewriting this, 8 on the left side is really just 8 over 1, and we know we're going to multiply that by 5 1/2, so we need improper fractions. So 5 times 2 is 10 plus 1 is equal to 11, so this is going to be 8 over 1 multiplied by 11 over 2. It's the same thing, just going one step ahead because I know we're going to have to do that in a little bit. On the right side, we still have this f over 8, or f divided by 8, and the 8 that we wrote on the right side as a fraction is 8 over 1. On the left side, feel free to just multiply, but if you want to cross cancel, the 8 and 2 make a 4 and 1. So 4 times 11 is going to be 44 over 1 times 1, which is 1, and that simplifies down to just being 44 on the left side. On the right side, these 8s are going to cross cancel and make 1s, so we're going to have 1 times f. Dropping the 1, we can say that 44 is equal to f, and turning it around, we can say the solution is f is equal to 44. There's our answer. Here's where we used our two properties. For example 10, we have g divided by negative 8 is equal to 3 and 1/2. So if we're solving for g, we need to get rid of this divided by negative 8, and to do that, we can multiply the left side by negative 8. If we do it on the left, let's go ahead and do it on the right. Let's rewrite this now. So negative 8 as a fraction is negative 8 over 1, and that's going to be multiplied by this g over negative 8 that we started with. That's on the left side. And on the right side, let's go ahead and turn this 3 and 1/2 into an improper fraction. So 3 times 2 is 6, plus 1 is going to be 7. So 3 and 1/2 is the same thing as 7/2. And we're going to go ahead and multiply that by the negative 8, which is negative 8 over 1. On the left sides, these negative 8s are going to cross cancel to make 1, so we can go ahead and write 1 times g on the left side of the equation. On the right side, we could just multiply 7 times negative 8 and divide that by 2 times 1, or we could cross cancel the 2 and the negative 8 to make 1 and negative 4, and then just multiply. So 7 times negative 4 is going to be negative 28, and 1 times 1 is just 1, so this simplifies down to negative 28 on the right side. Dropping that 1, we can say that our solution is g is equal to negative 28. There's our answer. There's the two properties we used, and we can check that these make sense. If we took 44 and divided it by 8, we would get 5 and 1/2 for number 9. And for number 10, if we took this negative 28 and divided that by negative 8, we would get a positive 3 and 1/2. Both of these answers make sense. And there you have 10 different examples on solving one-step equations that have division or a fraction bar as the operation. So to solve each of them, we use the multiplication property of equality, and then we use the identity property of multiplication. If you found this video helpful, I'd love to hear from you in the comment section down below, and if you don't mind giving the video a quick like, that would be really appreciated. As always, keep up the great work, and I'll see you in the next one.